We have, I'm not going to call it speed dating, but we have 25 minutes together. So I'm going to ask for some very great focus. And this is an audience, and Ashraf and Marco, we've done sessions together, and Namkoong, it's great to see you again, that it's not as familiar as of the terminology about the energy transition and what resilience is. And Ashraf, I wanted to start there because resilience could mean many different things to different people. Resilience in terms of making sure there's security of supply. It has to be affordable, if we're thinking of the energy triangle, if you will, and it has to be sustainable as we try to maintain net zero targets. From the Aramco perspective, how would you define how we build an energy system that is resilient and meets those three criteria, if you will?
Well, thank you, John. First of all, it's great to be here along with the esteemed members of the panel. And I think it's timely that we talk about the topic of the infrastructure, because in our view, this is a topic that has been a blind spot in the global discussions around energy transition, and not enough attention, in our view, that is paid in discussions around the infrastructure of the energy. But before we move into the definition, just allow me to take a few seconds to just paint a backdrop on what is the scale so that we can all appreciate what is at hand here. So the global energy infrastructure is one that provides 330 million barrels of oil equivalent per day. That's roughly 630 exajoules of energy to power a $110 trillion global economy and serving the needs of 8 billion energy consumers. If we look into the future, we expect that the global economy is going to double in size. We will have 2 billion more consumers joining the energy demand. So all in all, we expect energy to grow even more. And our energy system or energy infrastructure will have to cater towards that need. So what does it mean to have a resilient, sustainable infrastructure? It's exactly what you just mentioned. It's an energy infrastructure that provides affordable energy to developing countries to help grow their economies. It's an infrastructure that has to be robust to withstand any disruptions and is able to recover very quickly. And finally, it's a sustainable infrastructure that allows the whole world to transition into low carbon economies to meet the mandates of climate change and climate initiatives.
Okay, very quickly as a follow-up, I saw His Royal Highness Prince Abdulaziz's presentation yesterday to this distinguished audience, and he talked about low carbon intensity oil, and he was suggesting that the crude here from Aramco in particular, because of both the quality of the crude but what's been invested, is 1/8 the intensity of US output and 1/4 of Brazil. And I don't think this audience would know why that matters, but why does it matter in terms of the transition and energy resilience, would you say, Ashraf?
Crude is not all equal. We take a lot of pride that Aramco's oil is the lowest in carbon intensity globally, but that's not by chance. You know, we have had a very long track record since the inception of the company in building energy systems and energy infrastructure that is built on the highest efficiency standards and requiring lowest emissions. And it's not just by oil. Maybe we could start with the oil. Why is Aramco's oil is the lowest in terms of emissions? Throughout our 90 years, or 93 years to be exact, of operation, we've established a track record of building an oil infrastructure to produce, stabilize, transport, store, and export oil using the highest efficiency standard, while monitoring emissions and making sure that minimizing emissions is part of our mandate. We've also taken that into our gas processing, and that's not new. In 1970s, when Aramco built the master gas system, you know, one of the immediate byproducts of building that 3,000 kilometers network of gas to provide input or feed into many industries is that it helped us almost eliminate our gas flaring, took out almost 97 million tons of CO2 emitted to the atmosphere. So emissions and efficiency dates back to the 1970s when it comes to Aramco operations. You look at our power network as well. We've built close to 17 plants of cogeneration to provide power and steam. Those were also built on the highest efficiency standard and allowed us to reduce about 7 million tons of emissions from our power generation network. All of these factors together, if you notice, the common thread is minimizing emissions, maximizing efficiency. This has been part of our DNA since the company's inception in the 1930s.
Yeah, thanks for the description there. Marco, we could approach your expertise in many ways because of your previous experience and now working in hydrogen and the e-fuels market. How do those two products fit into resilience in your view? And do I have it right? Because there was a lot of government support for solar and then wind development. Do we need the same for hydrogen because the offtake is expensive, but you still think it holds a great deal of promise in the transition? By the way, you're rolling a picture. I hope it's a good one.
I think when we talk about hydrogen, we need to really focus on that infrastructure question and that resilience question. Because the era of negative interest rates, when governments could hope and dream, in Europe in particular, to put hundreds of billions of dollars to completely overhaul the energy system and the industrial system, those days are over. And so the balance sheet, so to speak, of governments where hydrogen demand is expected to be the highest and where some of the renewable targets are the most challenging, the resources of those governments are just very much strained. And so that's why for hydrogen to succeed, it must follow the path of renewables, which is very much in line with the previous COP or the last COP, which is about a gradual and just transition. Because renewables started making their way into the power grid without consumers having to do anything about the infrastructure. You flick on the switch at home, and you don't know if that's coal-based, nuclear-based, oil-based, gas-based, solar, or wind. It's not your problem. Whereas if you expect every single home in Germany, for example, to switch from gas heating to electric heating, you have to overhaul the entire home, every single home in Germany, to get to those results. So I think those days are over. Hydrogen will function because it will become a fuel, an e-fuel. We're already seeing some very big projects happening in the United States for eSAF. We're talking about big capex, but small volumes. In particular, what we are doing, which I think lends itself perfectly to the Middle East, to a country like the Kingdom here, and in yesterday's speech, His Royal Highness was very clear about the palette of options that exist, and I think that idea of low-carbon fuels is the future. We need to start measuring the carbon intensity of the solutions, otherwise we're comparing apples to oranges and throwing a lot of money backing technologies that then, once you've backed them, you discover you have to change the entire infrastructure. That simply will not happen. So e-fuels, just to make it simple, is basically identical to a fossil fuel, but made with renewables. So hydrocarbons means hydrogen and carbon combined. So one of the chief hydrocarbons is methane, natural gas. That's CH4. That means it's carbon combined with hydrogen. So what we're doing, for example, is producing green hydrogen made from renewable energy and combining that with CO2, and then you get synthetic methane. Now, it's going to start very gradually, so we can start putting in a 1% blend like they want to do in Japan into the grid. The customer doesn't notice. No new infrastructure. So those are the types of solutions that you can put in place today. You can scale them up gradually. They work alongside conventional fossil gas, and then 1%, 2%, 3%, going all the way up to whatever percent each government wants to get to. But to think that overnight you can switch the entire energy system or the entire industrial footprint will just cost a lot of money. And so when it comes to, this is a very topical moment to be having this conversation, because resilience means essentially leveraging the hundreds of billions of dollars that we have already spent. And when Amin says that the cost of the transition is 500 trillion, I think was mentioned just now, 500 trillion,
I think it's 100 to 200
100 to 200
but still, it's a heck of a lot of money.
There's a fundamental difference, because the beauty of some of the low-carbon fuels, fossil fuels produced here, and other blessed parts of the world, is that they have fields with a long life. But there are fossil fuels being produced offshore in Europe, for example, which have a very rapid decline rate. So the 100 to 200 trillion of capex that Amin Nasser is talking about, that generates almost forever fuels, like drilling some of the fields that were discovered here 70 years ago that are still producing. So we need to be looking carefully when we compare apples to apples, and some of the capex that will be put in place for solar and wind. Once you put in that capex, the marginal cost of those energy projects is almost zero, because the marginal cost of the sun and wind is zero. Like the marginal cost for some of the very old oil fields here or gas fields in Qatar is also very old. So I think the transition has to be just, has to be gradual, has to use the existing infrastructure, has to be pragmatic, can't be betting on technologies that don't exist now, but by scaling it up, we will make the renewables cheaper. And just one important point to the 8 trillion to 10 trillion people, a lot of the developing world, the so-called global south, is now running on diesel. And not many people realize that Manhattan is also running on diesel. Manhattan has some of the cheapest natural gas, but the state has prohibited building new gas pipes, so they don't have any power, so they need to burn diesel to keep the lights on. That's horrible news, because you have very cheap, low-carbon gas available next door. The so-called environment policies actually are worse for the environment because you're burning diesel. The good news is that the renewables that you can bring into Nigeria and other developing economies that are now running on diesel can cost a lot less than diesel. So there is a lot of capex, 100 to 200 trillion of money that has to be spent. But there also are some low-hanging fruits where when you go from a diesel-based 30% efficiency generator to solar with a battery, you can get cheaper energy as well.
Okay, good. We have about 11 and a half minutes, so I'm going to ask on the second round after we have Mr. Namkoong address this issue as a consumer of energy, to try to keep your interventions to 2 minutes from this point forward. Samsung E&A, which is Engineers and Ahead, is a consumer of energy, but you do large-scale projects. So in your building of a resilient system, what sort of efficiencies are you trying to get here, so for building materials and major projects to make them more efficient and meeting the need of being sustainable at the same time, would you say, Hong?
Okay, thank you for your questions, and the good and also the very difficult questions. However, the people came here, I thinking about very hardly on these topics, but we are all together work to find out solution these difficulties. But all panelists came from energy producers, but our company not only is energy consumer, but we also focus on reduce energy. Okay, so we, Samsung E&A, as an EPC, like an engineering, procurement, construction company, tried to focus on enhance energy efficiency. And we also consider of this when we design and build the plant. For example, get to your questions. When we built large plant here in remote desert areas, we needed to set up our camp for accommodations and bring workers and equipment to build plant. In order to this, we have no choice but to select major part of construction work, move to offsite for effectiveness. Then through this one, sorry, I just summarized the things. Okay, say again. Through this plant construction and offsite, then our solution is, I say, very sorry, but for example, when we built large plant in remote desert area, we need to set up camp and bring workers and equipment. Our solution is major part of construction work to offsite manufacturing facility. So under these controlled environment conditions, we create efficiency and continuous operations. Hence, savings energies, thereby reduce the schedule. In longer term in a construction site, we use also AI to improve efficiency. This AI required a lot of energy, but it increased productivity. And also, we use AI for overcome in limitation of traditional efficiency business. The key to energy savings here in higher efficiency. In other words, energy savings through reduce the schedule. We improve productivity and also reduced carbon emissions, dust, and other pollutant. For players like us in working in EPC business, we bring value to our client and our return on investment.
Good, so it's an evolving business. Thanks for, I know English is not your first language, and Hong and I were in the gym together, and I think he was playing his answers in his ear, so it was quite good. He's very disciplined in the approach to participating in the panel, so we appreciate it. Before I come back to Ashraf, Marco, we had two major reports out this week, one from the UNFCCC saying that if we go at this pace of the transition, that we're looking at 2.8 to 3.1 degrees centigrade by 2100. A lot of people left out the timeline. And the second one is that emissions never been higher because we've had droughts and we've had forest fires all over the bloody world, and it's accelerated the growth of emissions as opposed to a target to reduce emissions by better than 40% by 2030. How do we close this gap on reality? We have an energy system trying to be rebuilt, put in place an energy transition, bring in hydrogen and e-fuels that you're talking about, and try to live up to these targets when we're late to the party, to be honest, right? We've had these conversations for 30 years. Now the industry's moving at a fast pace.
Look, I think there's real progress being made on methane emissions, for example. The industry really got together and really addressed this issue that was raised by some very smart NGOs and not-for-profit organizations and put the issue out there. There's not much we can do on the worst part of emissions, which is the unfreezing of a lot of the land that has methane trapped under the frozen ice. That's very hard to mitigate. In terms of fires, I think there's a lot of improvements that we can do on power lines. A lot of the fires are linked to sparks from the
But I'm getting at, can we stay on track for net zero by 2050? Is it realistic, this conversation?
I think you cannot take the onus for the fires and the natural induced emissions. Direct air capture and carbon capture in general are something where we collectively need to spend more time and more capital, because that's a way of, again, using the existing infrastructures, creating a resilient system. The amount of progress that can be made on direct air capture is really exciting for me. The low-hanging fruits are getting rid of those more expensive marginal oil developments. A lot of capital is still going on developing small near fields that literally have the life of 5 or 6 or 7 years. That capital put on electrification creates a lower hanging fruit. So rather than trying to focus on changing people's homes or people's infrastructure, we should really focus on the wholesale part of the energy system, trying to capture those arbitrages that exist. So I'm quite optimistic that we will be building a gradual transition using the existing infrastructure that will be resilient, that will be cheaper, and that will be secure. I'm not at all optimistic that we will hit the targets, because it's a cycle that the hotter it becomes, the more ice melts, the more tundra ends up emitting natural emissions. There's not much we can do about that.
Wow, it's a pretty tough game, right? Because we had the Rio Agreement in 1992, but I think in the last 10 years, there's been a lot more focus, and then we're trying to accelerate the pace. I'm glad you brought up kind of R&D and capital allocation, because I think it's close to around 10% of capital allocation for Aramco as a company is to cleaner fuels, right? And blue hydrogen's a major investment, and I saw His Royal Highness's presentation yesterday on that carbon capture that Marco brought up. And your game, literally, as a producer's oil, gas, blue hydrogen, aqua power handles green hydrogen, solar and wind. What can you do to move the needle on that front, would you say, Ashraf, as a company?
So I'll remind everyone with what our CEO Amin said yesterday. He did highlight that Aramco is investing heavily in new energies, particularly in hydrogen, renewables, and carbon capture and storage. couple of years ago, we announced our ambition to produce around 2 million tons per annum of blue hydrogen, which is roughly 11 million tons of ammonia. We didn't stop at the ambition level. We took bold steps. We have bought 50% of a hydrogen hub in the east coast of the kingdom to provide low carbon hydrogen to industries there at competitive costs. This is a hub that could easily be changed to an export play with minimum enhancements. Together with SABIC, we've demonstrated 3 blue hydrogen shipments to Asia to test how the value chain of blue ammonia is going to work and to actually see what that production of hydrogen to blue ammonia would do to consumers and power generation companies in Asia. In carbon capture and storage, we are getting ready to start with the world's largest carbon capture and storage facility here in Saudi Arabia. It's a 9 million tons per annum facility that we're building. This project is not only going to help us meet our net zero ambitions and reduce our carbon emissions, but also to unlock the potential of blue hydrogen to many markets, including Asia customers.
Okay, very good. Mr. Namkoong, we're almost out of time, but
Yep.
I wanted to ask you about the project in Ras Al Khair, because it fits into the strategy as the largest economy in the MENA region to be a manufacturing hub. So it's not, products being produced in Asia, United States, and Europe, but actually in the region.
Yep.
What is Samsung doing here with Ras Al Khair and manufacturing?
Okay, so making big investment in one location is very big difficulties because current uncertain market situations. Surprisingly, our manufacturing hub is one of the ideas. This is really our built-in resilience is combining local manufacturing and our global network.
Interesting. And part of it's a geopolitical decision.
Okay.
Is it not stability?
Sure.
Is what you're saying in the region, in this
So-
Gulf country.
Yeah, so, we are not building a facilities, but we building creative manufacturing ecosystems. The manufacturing hub is a combined concept of supplying, fabricating, and constructions, and transporting material and machines to construction site. This is construction work from a low productivity site to high productivity offsite.
Okay.
Then this manufacturing hub, we are not only in one location. We consider several locations in order to respond to market situations and geopolitical issues. The first of all, while there are many local fabricators in Kingdom, the manufacturing infrastructure further needed to be improved. Our manufacturing hub is served as the production platform for them, and we also plan to suggest and heavy equipment and facilities and production expertise to this for small, medium-sized local fabricators.
Okay, perfect. Let's leave it there. That's very interesting. I'm going to give you the final word on that in 30 seconds if you can, because it was in His Royal Highness's speech and Amin Nasser talked about it as well. With the bouquet of different energies you're offering here, oil, gas, low carbon on the hydrocarbons, and then the hydrogen, both blue and green, can you really be the manufacturing hub that the kingdom is aspiring to in the 2030 vision?
Oh, absolutely. I mean, we believe that the kingdom is well positioned to provide, low carbon fuels. We've got among the most competitive energy prices in the world. With the help of Aramco, we're availing low carbon solutions for many of the manufacturers. So think about it this way. Instead of producing hydrogen and exporting it, a lot of these manufacturing capabilities can come to the kingdom, and then you export low carbon products by manufacturing it and making it here in the kingdom.
Great. Thanks for adhering to the 30 seconds. We could go for another half hour because the complexities of the energy system, the shock of the geopolitical issues that hit supply in the last 3 years, and then trying to stay on track with the transition is complex, but we appreciate the very direct language. Ashraf Ghazzawi, Marco, nice to see you again. Alverà, and Hong Namkoong. Thanks for wrestling through using the English language because we didn't have Korean translation for you. Can we give them a nice round of applause? Thank you very, very much. Nice.